In Chapter 11, we looked at various ways of constructing binomial models, and it was noted that the binomial models produce stock prices at a fixed point in time whose probability distribution approached a log normal distribution as the number of steps in the binomial model increased and went to infinity. Or another way of saying that, as the time intervals implied by the binomial model, the time steps decreased to 0. In Chapter 12, which we'll analyze in 6 modules, discusses the Black-Scholes formula, probably the single most famous formula in finance, and it was the first research paper which developed the price of an option using the methods of replication and risk-neutral pricing. The paper relies on much more advanced mathematics than the binomial pricing, however, the stock distribution assumed in that more advanced mathematics, which we'll see in a later chapter, the mathematics assumed ultimately relies on log normal distributions of stock prices at future points in time. So what we are going to study in this chapter is, if we explicitly assume log normal distribution of stock prices, what are the prices of options? And these are the prices given by the famous Black-Scholes formulas for European options. And sometimes these formulas are called the Black-Scholes-Merton formulas in recognition of Robert Merton, whose research contributed significantly to this early work. The binomial lattice method, interestingly, although it's a simpler mathematical model, was not developed until 10 years or so after the Black-Scholes result was developed with a much more complex mathematical framework. So it took, if you will, 10 or more years in order to understand this very deep result sufficiently to, in fact, develop it in a simpler model. The first module in this chapter will be just what are the Black-Scholes formulas, and we'll take a look at them and understand what the assumptions are in them. The Black-Scholes formula, as I mentioned, is actually 2 of them, but the Black-Scholes formulas are for European options and not American. There's not an American option counterpart to the Black-Scholes formulas. And the reason is that European options, as we've seen in our binomial lattice work, can be priced purely in terms of the expiry values of the option. American options require information throughout the period of time during which the option is exercisable. So there can be no such formula. The Black-Scholes formula does reflect the exercise values of the option. It'll assume a T-year, European call or put, strike of K, common terminology. S will be the value of the stock. Delta, as always, will be the continuous dividend rate on the stock. And as I mentioned earlier, that this formula is based on continuous time model of stock price movements, which we're going to get to in a later chapter, in contrast to the discrete time binomial models, where we have a discrete, we break up time in discrete steps and only model prices at the end of those steps.